All right, here we go. So you just did inverse trig on the calculator, but that is, the reason you learn that skill is so that you can apply it to certain maybe future situations. So I've come up with 4 different examples that I think are legitimate where somebody, maybe not you, but somebody has to actually use this in real life. Okay? All right, so here's the first one. All right, a toddler needs rescuing from a burning building. Okay. All right. So perhaps the toddler was in one room of the apartment and some fire caught and the parent could not get to them through down the hallway. They were blocked by fire or something had happened, so the toddler needs to be rescued. All right. So in comes trigonometry to the rescue. All right. The fire department arrives with a 300-foot ladder. To reach the window 82 feet off the ground. So somebody, and these ladders, it's not like they're running up with one of these just a ladder. It's one of these ones on a truck, and it's, electronic, and you have to program the truck to put the ladder at the right angle. Okay, so what elevation angle should they program the ladder to be? Okay, so what elevation angle should they use? No, you don't have time for that. You don't have time for trial and error. Sure you do. The math problem doesn't take very long at all. All right, so maybe not real life. All right, here we go. Here's the little window. Okay, we're trying to get to the window. We know that the window's 82 feet. We're going to lean the ladder up against the building, thus creating a right triangle. All right, so the sides of the right triangle are as follows. Where do we put the 82? Okay, on this side of the triangle here. Where do we put the 300? The hypotenuse, that is the... Okay, and then we are asked to find elevation angle. So the elevation angle is alpha, down here in that bottom corner. So the relationship between alpha and 82 and 300 requires what trigonometry? Sine or cosine or tangent? Okay, this is sine because 82 is opposite and 300 is hypotenuse. So this is the sine of alpha is 82 over 300. And then we just have to get alpha by itself, which is what you were practicing last night. So to get alpha alone, which is the angle of elevation, we'll use the inverse of sine, and we'll apply that to 82 over 300. So go ahead and grab your inverse of sine. Go ahead and grab your calculators. Make sure they still stay in degree mode. And tell me what the angle of elevation should be. Say it again.
15.8.
You're not in degree mode, I don't think. Oh, I've heard 15, I've heard 55, I have heard all kinds of crazy things. What? Units? Feet? This is an angle of elevation. Degrees. Okay, degrees.
In my head, I was thinking about...
All right.
How the older.
Okay, let's go out to the canyon.
You were literally, wait, your college could say?
Okay, a person on the canyon rim edge spots a hiker below. Shh. Okay. 450 feet away along the ground. Okay, the canyon is 1,080 feet deep. Find the angle of depression, or find the depression angle. Okay. So we've got one person up high, one person spotting a hiker down below. We know some of the dimensions of the measurements, and so we need to find the depression angle. Some of your homework problems are going to have a pre-made drawing for you, and then others you're going to have to draw on your own. So if we're looking at this, if I'm picturing someone standing on the edge of the canyon rim, looking at someone else down below. We know that the canyon is 1,080 feet deep, and this forms a triangle between the two of them. So where do I put the 1080? The canyon is 1,080 feet deep, and then I've got the 450. Where do those numbers go? No, the 1,080 does not go on the hypotenuse. Okay? Okay, what measurement goes along the ground? That's the thing to start with first. 450 feet along the ground. So that's the 450 here. Okay, so where does the 1080 go? Okay, it's the height. That's just the depth. Okay, now I want the depression angle. The depression angle is outside of the triangle I've drawn. The name of the angle inside the triangle I've drawn is the beta angle. So I actually have to find the beta angle first, then I'll be able to figure out the depression angle. So to find what trig relationship uses both the beta angle and the other two sides of the triangle? I'm sorry? Tan. Okay, we're looking at tangent because we want to relate the opposite side over the adjacent side. So this will be the tangent of the beta corner. It's going to be 450, which is opposite, over 1080, which is the adjacent side. So beta by itself is the inverse tangent of 450 over 1080. So grab your calculators and find me beta. 22.62? Just flat out, there's nothing else beyond the...
No, it's 6198, so then would that just...
Oh, so 620.
Okay.
Because if it's 19, which rounds up to 20, then it's 20. All right, so the beta is 22.620 degrees. I still am waiting, though, for the angle of depression, which is, the complementary angle. Complementary means they're related by 90 degrees. So we end up with 67. Okay, 67.380. Okay, so we've done a ladder, we've done a canyon. Next is the pool. So, so we've dealt with people who are going to be first responders, perhaps. Okay, dealing with people who are going to maybe work outdoors, work in a national park someday, something like that, trying to find a lost hiker. I know, it's broken. The air. It's broken. I know, I feel it. Okay, all right, next, maybe you're going to be an engineer. Okay, maybe you're going to be an architect, and you're called along, by a client to design something. And we're going to design a swimming pool. All right, so design a pool. $60 meters wide, with a deep and shallow end of 9 meters and 4 meters respectively. You know that when you read something and you see the word respectively, that tells you that when they have two words, two nouns, like the deep end and the shallow end, and then they give you two numbers, 9 and 4, that those match up. The first and the second one match up. That's what respectively means. All right, so then what you need to determine is find the depression angle of the bottom of the pool. Okay, so find the depression angle for the pool's floor. Okay, so you're coming up with the plans. You're going to hire a contractor or somebody to come in and dig you the hole for this pool you've designed, and you want to make sure you give them the right instructions. So again, you have to come up with a design. This pool's got to be 60 meters wide. It needs to have a deep end. That's 9 meters deep. It needs to have a shallow end. That's 4 meters deep. So we're looking at a cross section of the pool. I'm not looking at the pool from the top. I'm looking at it from the side. And then I need to have the bottom of the pool. Okay, so then we'll fill that pool with water. Where is the right triangle in this design?
It's where the 4 meters goes across.
Okay, so some of you see a right triangle coming across this way, perhaps. Okay, others of you might see a right triangle going down this way. Either one is fine. Okay, either one is fine. All right, I am looking for, okay, let's go with this right triangle that I've drawn in yellow. Okay, what do we know about the sides of that right triangle? 60 meters across the bottom, same as the other. How about the other side? It's 5 meters, okay? And we are trying to find the angle of depression. So I'm going to have to zoom in here a little bit. My angle of depression is going to be in here, which means I need to find my beta corner first. So I'm going to erase that.
Why did you put the theta sign so far away? Why can't you just put it right above the...
I can. I just had that line and that was blocking it, so I was just I'm cleaning it up now. There. All right, so this relationship one more time is going to be tangent, relating the 60 and the 5 together. So I'm going to go for the tangent of beta. Tangent of beta is the 60 over the 5, which actually reduces nicely to the number 12. So I can say that beta is the inverse tangent just of the number 12, which is not so bad because 60 and 5 reduced well. All right, what does that turn out to be? 85.236. Thanks, Janelle. Okay, so that is beta, but it's not the angle of depression. And so we would then need to use the complementary rules for angles to figure out that the angle of depression is 764 degrees. All right, one final example, and this has to do with a boat. And when we're working with a boat, we're most likely working with bearing. Okay. So perhaps you are to work in an offshore oil rig. Okay, you're going to be one of the people who, if you've ever gone out to the yes, where the oil rig exploded and Deepwater Horizon. There you go. Okay, perhaps you're destined for that. Okay. All right, a ship transfers workers from a pier. If you've ever gone out to the Seal Beach Pier, There is a place where there's a boat that comes and docks up at the end of the Seal Beach Pier, picks up workers twice a day, and then off, if you look out, you can see an oil rig right out there. And they just take the workers back and forth for their shifts. So from a pier offshore to an oil rig. The charted course is two miles west, half mile south. Okay, what's the heading? What's the bearing used? Okay, so what bearing is used? All right, so let's see if we can get a picture of this in our head. The boat is going west and then south, at least that's the charted course for this. So we have to imagine we've got the end of the pier. Okay, here's your pier. Here's the end of the pier. So the boat starts there. It goes 2 miles in a western direction and then only a half a mile in a southerly direction out to that oil rig out here. And we want to know what the bearing is for that right triangle. So there's your right triangle. Do you need the hypotenuse to figure out the bearing? No. Okay. All right, but what we've got is I'll put theta in there so I can figure out my bearing. So one more time, I've got the opportunity to use tangent. So I have tangent of my theta angle is the half, which is opposite, and the 2, which is my adjacent. That can simplify also. That simplifies to 1/4. So theta by itself would be the inverse tangent of the value 1/4. So using our calculator for the second to last time, what's our angle bearing, or it's our theta value right now? Say it again. 14.036. Is the theta measurement the same as the bearing measurement? No, because a bearing measurement starts at what compass heading? Starts north. So what I know right now, zoom in on this, this turned out to be, say it again, Greg, 14.036. Okay. That's that degree. That is not the bearing degree. My bearing degree, let's think about a compass here, and north is the top of my compass. I have to measure the angles from north to that hypotenuse length. Yeah, we have like 2 minutes. All right, so when we measure it, we want to go around this way to figure out the bearing. That's going to be your bearing, starting from north, swinging around. So as we swing through those quadrants, we're going to pick up 90 degrees. We'll pick up another 90 degrees. We've got 90 here, another 90 here. How much more do we have to go before we run into the hypotenuse, which is well, how much more here? Not the total, but how much more? It's not 194, no. Okay, just in this section here. How much more right there?
90 minus 14.
90 minus 14.036. So we've got 75.964. So put it all together to figure out the bearing. Because you got to have the 90 and another 90 and then the 75.964. So what's the sum if you add them all up? 255.964 is the bearing heading that the ship has to use to get from the end of the pier out to the oil rig. Plus 75.964, right. Bearing has to count for all the degrees that are up to that point.